Hello.
Hello. Good afternoon, sir. Sir, you are not audible.
Am I audible to you now?
Yes, sir. Yes, sir. Good afternoon, sir. How are you?
Yeah, very good afternoon. I'm good. Thank you,
Yeah,
sir.
it is nice to see you again sitting in front of me.
Thank you so much. Thank you so much.
Uh, shall I start giving you an introduction now?
Yeah, perfectly fine. Let me, Dr. Sasi, if you allow me,
Yeah.
I would like to just share my PPT. Okay, once
Okay.
let us have a small check,
Yes, sir.
and once that is done, then you can, proceed as per your standard protocol. Uh,
No problem, sir. It is up to you.
okay.
Like, if you want to start right after that, then that's okay.
Okay. Fine. Please, you can start. You can start. You
Yes,
go
sir,
ahead.
sir. Up to you, sir.
Perfectly fine. Dr. Sasi, please. Now, yeah, the steering of vehicle is with you now.
Okay. So good afternoon to all of the participants. Today we have Dr. G.D. Ransinchung from IIT Roorkee. I request all of the participants to please switch off their videos, cameras, and mute themselves because otherwise there would be some technical fault in the connection. So, good afternoon to all of the participants. Today we have Dr. G.D. Ransinchung from IIT Roorkee, a eminent professor there, who would be speaking here on the principles of structural design of bituminous pavement. And actually, his topic specifically is the materials used in various layers of rigid pavement and their properties. So now I would request our guide, my guide, Dr. Ranjan, to take over the charge and present whatever he wants to tell. Okay, sir, over to you.
Yeah, so what I do is I'll share my PPT first.
Uh, I cannot see, sir.
I think it must be now visible. Is it okay?
No, sir. We cannot see the PPT.
Okay, give me a minute. I'll just share it.
In the meantime, I request all of the participants to please switch off their cameras and mute themselves. I could see people having their cameras on. Yes, sir. Now it is presenting. Yes, sir.
Is it visible my slide?
Sir, it is still, now it is visible. Okay, sir.
Is it coming? Uh,
Yes, sir.
I'll just check up once. At times it should happen, the uh, the slide transition is very slow. Is it okay?
Yes, sir. It is okay. It
Okay.
is perfect, sir.
Okay. So well,
Please. Okay. Yeah.
can I start now?
Yes, sir. Yes, sir. Definitely, sir.
Yeah. Well, first of all, at the very outset, I would congratulate your team for your successful conductions of your program, and at the same time, I apologize profusely. During that point of time, I was not able to join you. I supposed to deliver these lectures. I think if I'm not wrong, sometime 15 July or so.
Yes, sir.
Yeah. So due to unavoidable circumstances, I requested Dr. Sasikan Sharma to kindly postpone if possible. So he was kind enough to consider my request.
Sir,
Uh,
pleasure is ours.
because of which today I got the opportunity to interact with you all. So therefore, I would say thank you very much to your team and Dr.
Thank you, sir.
Sasikan Sharma. Then, secondly, I would like to thanks all the, yeah. I think there is some
Yes,
background
sir. We are
noise.
muting them.
Is it
There are
okay?
still some participants who keep on switching their mics on. So we are
Yeah.
muting them.
So yeah, and at the same time, I would like to extend my thanks to these participants who are joining me right now. I know, uh, see, whatever the thought process that we have, we uh, today, I would say in that way, let me put in this way. Earlier, this kind of program we used to have, like we go there, we visit the institute and deliver lectures physically, and we got the ample opportunity to interact of the faculty of those institute physically, and had the opportunity to visit labs and all. So those opportunity is missing right now. But nevertheless, uh, our thoughts or our wisdom can still be exchanged. Even if we are in a different corner of the places. So that we are trying. So I welcome all the participants to my lectures. I'll try to apprise about the materials used in the various layers of rigid pavements and their properties, particularly in the constructions of cement concrete pavement, or quite often, many a times I may refer, rigid pavements or PQC or cement concrete pavements. So please, I would first of all would like to clarify that if I mention PQC, I I am talking about the rigid pavement. I'm talking about the cement concrete pavements, and I'm talking about the PQC. Okay, they are same. Like a person having three different names. So that clarification I would like to make first of all. So what I have done is before I invite you to the core of my presentation, briefly, I would like to come up in this way. Why rigid pavement? Okay, we have, as we know that broadly, we have different types of pavements, two different types of pavements. One is flexible pavements, okay, and a rigid pavement. So in flexible pavement, uh, the, the pavements is being constructed with the multiple layers, and the top layers is being constructed with the bituminous courses. But in case of rigid pavement, though there are, yes, few layers, but the numbers of layers involved in the pavement is comparatively less when we compare to flexible pavement. But here in rigid pavement, cement concrete slab would be considered as a in the form of bridge. Okay, it's a very stiff kind of materials, and which has a high modulus of rupture. Therefore, the load sustaining capacity is much higher than the flexible pavement. Therefore, I would like to briefly, compare, not the comparisons, a kind of justifications that I would like to, share with you some of the experts, along with the some opinions shared by the some of the experts. Okay, so some of the experts says that why rigid payment. So it says that right, a huge amount of taxpayers' money is spent every year to add one or more coat for tar. When I say here tar is I mean here the flexible pavement to make riding surface better, but it is often a cosmetic addition that wears off soon. So what do we do to make our road last longer without repairs? So the question is that. So then it says that now let us go for white top or white topping from the black top. So black top means flexible pavement, bituminous layer, and when I say white top, I mean that cement concrete pavement. So the expert says, yeah, a much better alternative to bitumen would be cement concrete. How and why? A small justifications based on the experts' opinions. If 170 tons of bitumen derived from petroleum crude is required to lay a kilometer of two-lane roads, about 900 tons of cement is required for the same distance. On the brighter side, about 330 tons of bitumen is required for the maintenance of streets for 20 years. If a properly laid bitumen road is likely to survive for a few years, then the concrete pavement lasts for more than 40 years. So a good example of this rigid pavement long-lasting concept is a Marine Drive in Mumbai, which was laid in cement concrete in 1939. It is still going strong. And also, it is claimed that the price of bitumen will go up from 35 rupees 35,000 per ton to about 3 lakhs per ton in the next 20 years, making bituminous construction too costly. It is thus imperative that highway engineers look at alternative binders. So cement is a promising alternative binder for the road constructions, and it says by the L.R. Kadiali, former Chief Engineer, Ministry of Surface Transport. You must be knowing, he was a very famous engineer. Now, uh, so he commented particularly on this, that cement is a promising alternative binder for road construction, and also the crude reserves worldwide are finite, and rough estimates predicts that the crude reserves will last for only 25 years. Then the road experts say limestone reserves in the country would last for more than 500 years also, and hence would reduce the cost of the road works. For instance, the price of bitumen, which was rupees 500 per ton in 1960, rose to rupees 30,000 in 2009, whereas the price of the cement, which stood at rupees 10 per bag, then has touched rupees 240 in 2009. So industry estimates reveal that the cost of bitumen is likely to reach 1.8 lakhs per ton in 15 years also, while the cement will cost only rupees 480 in the same periods. So, the Mumbai, which received an average annual rainfall of about 2,500 mm, has taken the lead in laying cement concrete roads in the country. More than 500 kilometers out of 1,941 kilometers of road network in that city has been cemented. So the geographic and topographic limitations, coupled with all developments, affect the surface runoff, and asphalt roads cannot last long, says, which was commented by Vishal R. Thombere, Assistant Engineer Roads, Brihan Mumbai Municipal Corporations. And also it says that a study by the Central Road Research Institute found that at least 14% energy of engine is wasted in overcoming deflections on bituminous roads. These are a very, in a very summarized manner. I just would like to put it across. Why should we go, by the rigid pavement and in lieu of flexible pavement? That was the story behind. There are more justifications, but due to paucity of time, I may not be able to come up uh, in details. Now, I would like to invite you to the rigid pavements and the materials. When I say rigid pavement and the materials, the reason being, when we construct a rigid pavement, there are the layers, couple of layers that we need to construct before cement concrete slab is laid. So for before that, I just would like to apprise you that how I compare the materials and human body. So in that way, I would say, like, our body is made of many components. For our body to function, flesh, blood, and bone must work together. So now, as we know that the skeleton serves six, different major functions: storage, platform. I consider that it's a platform and formation width of the rods, and the support. Support is nothing. I consider that it is a foundation, and then we have a blood cell productions in human being. But in terms of concrete, I would say, like a concrete pavement, it is a chemical reactions which is going to take place when cement grain is in contact with the moisture, and endocrine regulations. So this is, again, I compare with modifications and alterations within mix. Example like productions of calcium silicate gels, calcium hydroxide compounds in concrete, etc. And the most important, the parameters that required in rigid pavement is movement. That is the elasticity property, which should be, flex enough. But for the which, now what we do is at joints, we have to provide a proper jointing so that the flexibility of cement concrete pavement is maintained. Otherwise, what would happen? Unwanted crack is going to occur, and finally the stability property. So here from this skeleton, as you can see, this I consider this is the foundation. The bones are all these joints. We have the different joints in our body. So if you have to be healthy man or a healthy person, then you have to keep your this bones and your joints strong. The strong, when I say joint strong, in the sense that your joints should be very flexible. As and when required, you should be able to flex, you should be able to take in, you should be able to take out. That flexibility should be able to maintain without disrupting our body joints, for which in similar manner I took it in that way, even in the rigid pavement. As we know, the structure is very rigid, very strong, so very stiff. Okay, but there are in the constructions of rigid pavement, we have number of joints at a predetermined locations. The joints are mainly provided to relieve the uh, tensile tensile stresses and warping stresses, etc. So that joints, if we are not able to provide properly in the concrete pavement system, then I would say that it's going to be a really great disaster. Therefore, I uh, always consider in that way, in that perspective, that whenever we construct a rigid pavement, it is imperative for us to understand the requirements of the pavement. The first and foremost that we need to give our proper attention is towards the joint. So coming to Indian road network, the main concrete networks for the city roads was started in Mumbai in 1924. So rigid pavement within NHDP program is around 1,680 kilometer, equivalent 2 lanes under NHI and NH2 and NH60 in 2004-2005. So a good example of the expressway which was constructed by PQC is the Mumbai Pune Expressway. So there are now we have a couple of the same expressway. Apart from this, if I have to mention, we can like Noida and Agra. The Noida Agra, that expressway is also one of them. But I'm giving just a small example that now in India, now gradually we are also coping up with the rigid pavement construction concept, and it is being introducing in our this road network system. Now coming to rigid pavement, I would say this is how among the participants, some of them may be of UG students and MTech students who might not be familiar about the rigid payments, and some of you must be in a very advanced stage with respect to rigid payments. But my lecture has been prepared in such a way that all of us can understand better about the rigid payments. In such a manner, I have prepared the slides. So this is how the rigid payment is. It looks like these are the different panels of the rigid pavements, wherein dowel bars and tie bars are protruding outside. This is for the further construction. This window has been created for further construction. And if we look at the cross sections of the rigid pavement, we have the first and foremost that we need to build is subgrade. Subgrade is treated as the foundations of the pavement system. Regardless of types of pavement, subgrade layer needs to be constructed very firmly, because it is being treated as the foundations of the pavement system. In case of rigid pavement, we consider both CBR or K modulus of subgrade reactions. So CBR of soil is considered because it is easy to determine the soil supporting value, and from wherein we can convert it into the equivalent K value. So now in case of rigid pavement, K value is important, and based on the K value and for the given axle loads, we have to design the pavement slab. And and there are some supporting layers which are being participated in the form of drainage layer, and which are, some of them are participating as a separation layer. So in rigid pavement system, we term as lower subbase and upper subbase. We don't normally term as subbase and base, because base course is not uh, you know uh, is not considered in the rigid pavement system. In lieu of that, we prefer to term as lower subbase and upper subbase. Now, in case if we intend to provide GSB of two layers, one is for, say, for example, uh, of a well-graded GSB, and another is another layer of the considering the solely the drainage aspect. If we happen to provide that, then there are in the mode close 40 in the mode clause 401 sections of GSB layers are recommended for different applications. So now the GSB for drainage layer is uh, slightly gap graded, and if the GSB is provided for as to be an integral part of the pavement system to sustain the load, then it would be more well graded. So now in the mode clause 401s, there are different gradings. Grading 1, 2, 3, 4, 5. Okay. So accordingly, we have to opt the that aggregate skeletons for constructions of this drainage layer. And then subsequently, DLC layer is constructed. DLC layer is also known as a subbase layer, but this would be termed as a upper subbase. And upon on top of this DLC layer, we provide uh, a separation layer of PVC having a 125 micron thick. This PVC layer is sandwiched between the DLC and PQC, so that there is to break the bond between the PQC slab and the DLC. So in that way, we are likely to have uh, different layers of like GSB and DLC and then PQC. So now our talk would be based on the layers, materials required for constructing these different layers. Now, coming to types of rigid pavements, I would like to share with you like that. Here, there are jointed plain concrete pavement and jointed reinforced concrete pavements and continuously reinforced concrete pavements and roller compacted concrete pavements. So we have, I would say, there are 4 different types of rigid pavements. The good example of jointed plain concrete pavement is that here we can see in this figure 1, though the name implies that jointed plain concrete pavement, but here in this concrete pavement system, we do employ dowel bars and tie bars at joints. Now, joints are normally provided at the distance of 4.5 meter interval. Now, this rigid pavement is designed as per IRC 58 2015. So IRC 58 2015 is designed for the slab size of 4.5 into 3.5 slab panels. So therefore, it is imperative to provide a contraction joint at the intervals of 4.5 meter. So in that way, at, at every 4.5 meter intervals, we need to provide the dowel bars, and the tie bar is again provided in the longitudinal directions, and tie bar provision is required, is made when the carriageway width is more than 4.5 meter. So if the carriageway width is more than 4.5 meter, then the length is normally divided into two equal parts. So in the middle of that carriageway, the longitudinal joint is normally provided. Now, the functions of dowel bar and tie bars are like, dowel bar is a load transference, load transfer device. So this is solely for load transference from one slab to another. And whereas in the case of tie bar is not a load transfer device. It is solely provided to catch hold of the adjacent slab firmly. So in that way, they have their own, different functions. Hello, hello,
What happened, sir?
am I audible to you?
Yes, sir.
It seems I'm a bit, my voice is low, and probably the what do you call, the participants would be, I think, feeling bored. So I let me come up with energy. Okay.
Sir, I think it is going on well. I think nobody is getting bored. Actually, it is quite good, which you are telling. Right now, this slide is very important.
Okay. So let me come up with energy.
Yes,
Okay.
sir. Actually, you are sitting like quite far away from the laptop, I think. That's why.
Is it fine now?
Yes, sir. It is quite well. It
Yeah.
is quite loud
I know.
now. Yes.
I was low. I was low, and then my energy level was not up to the mark. Now I come up. Okay, I'll maintain my energy so that the participants also, enjoy my lecture.
Yes,
Yeah.
sir. They are appreciating. They are appreciating now.
So what I do is here I was trying to share my thought process pertaining to these different types of payments. In that we provide the reinforcements, dowel bars, tie bars, and different depending upon the types of pavement. Types of the rigid pavements. We provide the reinforcements as per the requirements. Like for example, I have just explained about the jointed plane concrete pavements a little while ago. Similarly, now for the jointed reinforced concrete pavements, wherein the reinforcing bars are provided, okay, to take care of the tensile stresses and all. But this method is now seldom applied. But coming to the continuously reinforced concrete pavement, yes, this reinforcing is being done at the neutral axis. This reinforcement is being done solely to erase cracks better, not to strengthen the tensile stress. Okay, as we know that concrete is more strong in a compression than this tensile, but the continuously reinforced concrete pavement system, though we have a reinforcing bar at the neutral axis of the pavement, this reinforcing bar is not going to help much going to help much in the tensile strength elevation. Okay, so that's how then the roller compacted concrete pavement, it is in short we say RCCP. It is a very upcoming upcoming kind of rigid pavement, I would say. Okay, uh, this in this particular types of pavement, we don't use reinforcing bar, we don't use reinforcement. Okay, and the kind of the design mix that require is a zero slump concrete, and that Abraham's law is seldom applied in formulations of the concrete mix for roller compacted concrete pavement. Now, whereas in the case of jointed plain concrete pavement, we need, the concrete mix which has a low slump of about 25 plus minus 10 mm also. So in the safer side, what I would love to say is that the slump shall be range in between I would say 20 to 30 mm also. But in the case of roller compacted concrete pavement, it has to be zero slump concrete is preferred, because the construction methodology is very comparable with the kind of the constructions which is being adopted for wet mix macadam, by employing a very simple roller and a very simple grader and a very simple that tipper. We can easily construct the roller concrete pavement. Okay, but whatever the case may be, I have mentioned here the different types of 4 different types of pavement as of now. So regardless of these types of pavement, the most important thing to understand is that the constructions of these pavements will be done by the concrete mix. Is it okay? Now, concrete mix. Now, only the difference in the concrete mix is that whether one type of concrete requires a low slump and one type of concrete requires no slump. Okay, very stiff kind of mix. That's it. Therefore, the formulations of concrete mixes is slightly different from each other. Very simple. Now, what are the materials required or used in the rigid pavements? Okay, so as you know, for the constructions of rigid pavements, we would need, like, if we right from the scratch, if you talk about, yes, subgrade layer construction is important, as I say. So subgrade layer is constructed with the help of soil, okay, locally available soil. So then what should be the quality of soil, right? That is important aspect for today's lecture. So now the soil is involved not only for the subgrade layer construction. The whole thing, that the whole idea behind is that we are trying to build a very robust kind of pavement system, that is rigid pavement system. So it doesn't, our discussion doesn't end with the subgrade layer construction. Our discussion would even extend to the embankment layer construction, depending upon the road profile, existing road profile. If we happen to construct a road in the low-lying area, then obviously we have to raise the level of the pavement, right? So for which we would have to, take care of the embankment layer construction. So that I will be talking in the subsequent slide. And then subsequently, when we go up to the surface side, then aggregates, right? Involvements of aggregates, granular materials. Aggregates are required for the constructions of, like, drainage layer, maybe in the form of ZSB, or maybe in the form of dryland concrete, and then the final top layer, that is the PQC, the pavement quality concrete, the cement concrete slab or rigid pavement slab. Then we have, like, sealants. As I mentioned earlier, that in the rigid pavement construction, we have joint. Joint is inevitable. Joints are to be provided at irregular intervals. Therefore, sealants. Sealants are a very important components in the rigid pavements, because the sealant is going to pour between the the cut joints. So when the slab is under the contraction or expansion mode, that at that point of time there would be stresses would develop at the both ends. So now, therefore, what happens if we don't provide a good sealants? Now these two slabs would come and would contact, collide, and then it may have some cracks at the edge, right? Therefore, if there is a proper sealant within it, then this sealants would absorb the stress
and again allow to goes back these slabs to its original positions, and as and when required, when the stress, the vertical and horizontal stress which is coming from the vehicles, that can be encountered well. That's what the sealant has to be properly selected and pour onto the joints. Yes. Now the most important ingredients is in a concrete mix is cement. Yes, cement is now treated as a binder in presence of moisture. Cement without moisture, it is simply an inert materials, no reaction. Unless until the cement comes in contact with moisture, there won't be any chemical reactions. So now for constructions of rigid pavements, like in the Indian market, we have different types of cement. Like PPC is one of them. We prefer PPC. PPC is what? PPC is the pozzolana Portland cement. Okay, pozzolana Portland cement is nothing. It is a cement blended with fly ash. Okay, then ordinary Portland cement, OPC. Now again in OPC we have different grades. OPC 33, 43, 53, and so on and so forth. So OPC 43, OPC 33 is low heat cement. Hence, for concrete pavement construction, we don't prefer. But OPC 43 and 53, they are recommended. But among these two these two grades of cement, OPC 43 is again preferred over the OPC 53. Reason being, again, OPC 43 is a cement which would liberate heat in a moderate rate. Now, why the moderation or release of heats of hydration is important? Yes, again, it is important for the reason that depending upon the heat liberations, the shrinkage cracks developments also influence. Therefore, in the cement concrete pavement construction, we gave more impetus on the heat of hydrations of the cement so that we can control the shrinkage cracking which is likely to occur on the concrete surface. Okay. Then now, as I said, in the concrete pavement construction, we need to give a more proper attention on the joint, okay, while providing the jointing. So during we provide the joints, we have to have the reinforcing bar in the form of dowel bar and thigh bar, okay. So the dowel bars should be now properly designed as for the given traffic conditions and for the grade of concrete you use. Okay, so the dowel bar and thigh bars are designed. Okay, otherwise, what happened as a rule of thumb in IRC 58 in 2015, we have a tentative guidelines based on the slab thickness. Okay, these dowel bar diameters are provided, and approximate the spacing of dowel bars also recommended. So these guidelines or this kind of table is provided for only for only those projects where the design facilities are very challenging, and if they are not able to expedite the design scientifically at their end, in such circumstances, in the worst case, they may refer this kind of guidelines. Otherwise, ideally the design dowel bars and thigh bars are to be designed for the given traffic load, okay, as well as for the different grade of concrete use. Now, water is again a very important ingredient in the concrete. Without water, the cement is not going to react at all. So the kind of water that we're supposed to use is the water quality conforming to IS 456. So in a very to simplify our discussions, we would say that it's a potable water that is drinkable. The water which is suitable for drinking is suitable for the mixing in the concrete mix, as well as for curing purpose. Then now, as we know, in the modern time, in this present scenario, the concrete. Now, when we say concrete, it doesn't end up only with the light mixture of aggregates, cement, water. Now we have different types of admixtures. Okay, mineral admixtures. Okay, there are more of pozzolans in nature. They should have. I would say there are pozzolans. Pozzolans having a materials having siliceous, substantial amount of siliceous components. Then light fly ash, light ground granulated blast furnace slags, or light sugarcane bagasse ash, or light silica fume, etc. Now the selections of mineral admixtures is again depending upon the requirements of the concrete mix, right? Now silica fume is it's a well-established pozzolans, okay, which has a substantial amount of siliceous, okay, in comparison to fly ash, in comparison to GGBFS and BZ, okay, but it is expensive in the market, okay. Therefore, the silica fume, use of silica fume is not preferred unless until now the situation is in a very dire conditions. But now, having said that, fly ash is abundantly available, okay, abundantly available, and it is, I would say, rather this is waste materials which is now every one of us, every in what do you call, every citizen is giving lots of concern in waste material. Hello. Hello.
You carry on. Actually, there was some participant who put their mic on. I have muted them.
So we have, okay. So let me not elaborate too much on this mineral admixture. So that what I want to say is that depending upon the availability of the materials, okay, we go by, because we have to economize the construction costs, and at the same time we shall be able to manufacture a concrete in such a way that the concrete is economical, and at the same time it is durable and it is very strong. Okay, so that's how. Then chemical admixtures, depending upon the again requirements of the projects. Say for example, if suppose the distance between the batching plant, right, your batching plant and the laying site is quite significant, then during the transportations, if you anticipate that there is a probability for a loss of slump, okay, in a very substantial manner. In such cases, we need to look at a suitable chemical admixtures, okay, to enhance the workability or to maintain the workability of the concrete, so that when the concrete reaches to the work site, we should be able to pour the concrete in a manner we desire to do so. Then next is the fibers. The fiber is again now in the modern concrete, we use the fibers in order to, as ingredients to control the post cracking and also the shrinkage cracking. So now the fiber is again mainly in Air Force, like okay, in Air Force, in a run in apron area or in a taxiway, like in such important locations, this fibers requirement is very high. So whenever, this is my personal experience, whenever I get a request from the MES or Air Force stations, they always prefer to recommend the fibers. Okay, so to control the, as I said, the shrinkage effect, shrinkage cracking, and the post cracking. Then yes, we have the suppression membranes. Okay, it is a 125 micron thick PVC sheet we provide. This has to be sandwiched between the DLC and the PQC in order to break the monolithic actions. Okay, so this suppression membranes has to be sandwiched. And then air entraining agents, again, in order to enhance the durability property of the concrete, the air entraining agents are sometimes admixed. Okay, and then curing compound. The curing compound is again now, yes, it is a very, yeah, I would say, a very essential ingredients or essential components to be considered while constructing rigid pavement. Once, because this curing compound is important for the reason that it helps in, you know, protecting the loss of moisture. Okay, once when we do the concreting, immediately when we finish the concreting activities, and then the curing compound needs to be sprayed across the carriageway width, across the concrete slab, so that the loss of evaporation of moisture is prevented under the solar radiation effect. Now, when we talk about the uh, uh, materials requirements, the properties of the materials which are to be, you know, employed in the different layers construction. Yes. Now, it is a kind of, I would say, I consider in that way, you know, the surgery, you know, surgery, that we are going to do the surgery. Okay. For civil engineering, the mortuary is a laboratory. Here, from this figure, what happening is the doctors and the nurse, they are, you know, performing the surgery here. But would they perform the surgery without proper diagnostic, you know, process? No. They will have to first of all rule out the root causes. Okay, what is the, you know, the root causes of this, you know, ailment? Then they would, once they rule out that, they know, okay, here this is the main cause, and at this particular location the problem is exists. So therefore, this at the targeted location only they can open up, right? So similarly, for our highway engineer also, we go to the laboratory, that is a mortuary for us, wherein we can do the so many, you know, postmortems on the aggregates and other construction materials, for which we therefore we need to understand the characteristic, you know, of the materials individually. Say now, for concrete mix, rigid pavement construction, for example, without a concrete mix formulations, we cannot go ahead, okay, with the construction activities. So for which we have to formulate the concrete mix. If we have to formulate the concrete mix, then what we supposed to do? We are supposed to, yes, understand the individual characteristics of the aggregates, so that when they are combined together, they should be compatible. You know, they should be compatible. Compatibility, degree of compatibility, okay, within the aggregate matrix is very, very important. So now, what is that degree of compatibility we are looking at? Yes, we are looking in it, you know, two main different aspects. Number one, yes, when we admix different materials together, they should not have any some, you know, chemical reactions, or so that, you know, they should not have any detrimental effect when they combine together. Number one. And secondly, they should be able to, you know, interlock. They should be able to have a good degree of interlocking among themselves. Okay, that way, because we believe that if the degree of interlocking is very high, then we are going to get the dense mixes, dense aggregate skeleton. And if we get the dense skeleton, then the volume of paste that, you know, we require would be lesser in comparison to open graded and which are not well graded, okay, mix for the same kind of aggregates, right? So therefore, proper investigations, okay, on the individual aggregates is imperative. Okay. Now, coming to the construction, coming to the cross sections of the rigid pavement, if you look at a glance here, I, you know, assume in this way. Now, the road has to be constructed from the NGL or OGL, original ground level or a natural ground level. So we check the suitability of the materials, whether this particular soil bed, you know, would be able to sustain the oncoming load. Okay, to do that, we measured the properties of soil in terms of CBR. Okay, the soil supporting value is measured in terms of CBR, California bearing ratio. That is in the shock condition. Why shock condition? Because we are assessing the properties of soil in the worst conditions when it is in the saturated conditions. Therefore, if we happen to construct a rigid pavements in a low-lying area, then we are bound to construct embankment layer. Okay, so the embankment layer that we're going to raise is a what? Formation land, formation width. We consider that. Now that is the platform, given to the subgrade layer. Now upon this, subgrade layer has to raise on it. Now subgrade layer is treated as the foundations of the pavement system. Therefore, we have a different, specifications. Okay, in comparison to embankment. Now, embankment has certain criteria depending upon the height of the embankment. For instance, like if the height of the embankment is up to 3 meters and not subjected to extensive flooding, then the maximum dry density that we supposed to attempt to get from that particular kind of soil should not be less than 1.52 gram per cc, and the CBR should be at least 5%. And the kind of soil that we use should be a non-soiling kind of soil. But if the soiling potential is there, that soiling potential, when we measure in terms of free soiling index, it should not be greater than 50% when tested in accordance with IS 2720 part 40. Okay, this we need to understand. Now, in another condition, now these conditions are for height of embankment up to 3 meters. If the height of the embankment is greater than 3 meters, then the criteria is slightly different, because we need a superior, kind of soil. That is, the MDD shall be at least, 1.6 gram per cc, and the CBR 5%, and similarly FSI should be less than 50%. Right. Now this kind of soil is required for building the embankment as a formation width. Then upon that, we have to build a subgrade layer. So the subgrade layer, and for the constructions of the subgrade layer, which kind of soil has to be selected? Yes, in that case, the soil now we are going to select is again based on the MDD, CBR, and the soiling potential. Right. Now see, let me put in this way. We are not less than the doctors who are sitting in the hospital. Okay, we are using our own tools and try to diagnose the soil properties and try to understand the soil properties, and based on that we have to take the further cognizance of that further course of action. Now in hospital, what happened? The doctors, when I'm not feeling well, I go to doctors and I approach the doctors. Now, right now, actually today I have, headache. Yeah, since for the past 2 days, I'm having a severe headache. Now, then what I do? I'll go to doctor and I'll ask, okay, doctor, I want to meet you. I take appointment. The doctor will say, yes, come. What do you want? What happened? What apprehension you have? Then I have to, vomit out everything. Doctor, I'm having this pain here, this, that. I'm having cough. I'm getting, headache. Then the doctors would list down your complaint, and accordingly, he is going to make the prescriptions as per their standard protocol of treatment. Then he will say, okay, my dear Mr. X, why you take this tablet, right? Crocin you take, and along with this antibiotic, and you see me after 3 days. That means he is not sure enough. He is, anticipating that it must be viral, because of which now he said, based on the information provided by you, by me, he is prescribing that medicine. Similarly, what I'm going to do as a highway engineer, I'm trying to understand the soil property first, okay? Whether this soil is going to, work well for this particular layer. Because now I have the specification. What is the specification? I have the specification in terms of MDD, CBR, okay, in terms of FSI. See, this is my standard protocol of treatment. Now then I'm going to start what I'm going to find the MDD. Now if the MDD of the soil is less than 1.75 gram per cc, then I say no, this soil cannot be treated or this cannot be imported for the construction of subgrade layer. And upon that, if the CBR of the soil is less than 8, then now I'm confirmed that this soil should not be collected for the constructions of subgrade layer, and so on and so forth. So now it becomes easier for an engineer to decide whether this soil is to be selected or not for the constructions of that particular layer. That's what, if you wanted to be a very successful highway engineer, you must be very strong in the specifications of the materials too. This is my sincere advice to my participants, mostly for the young the students who are looking keenly to work in the transportation area and particularly in the pavement area. Okay, then now I take you to the dry lean concrete. As I said, it is a sub-base layer. Okay, the purpose of providing DLC layer is to, first of all, to provide a smooth surface. Okay, to provide a smooth surface, free undulations. Okay, and also this DLC layer act as a capillary cutoff layer in case of any localized in a local area there is any capillary rise. This is a good I would say mechanism to cut off the localized capillary rise, and also it's a very much integral part of the pavement system which increase the load sustaining power of the pavement system. Okay, now on top of it, now for before that, let me put in this way: the dry lean concrete layer for the construction of the dry lean concrete. See, the name itself implies that dry lean concrete. Dry means now with very less water. Okay, with involvement of very less water. Lean, lean concrete means very with a small amount of cement contained in the concrete. Okay, so now from this terminology, what we understand is the mix is a little bit in a dry manner, means zero slump kind of concrete. Okay, we are looking, and the cement content per cubic meter of concrete is very, very low in comparison to PQC. So as per MOD clause 601, if you are familiar with MOD, means Ministry of Road Transport and Highways, clause 401, it is recommended for DLC dry lean concrete mix, minimum cement content recommended is 150 kg per cubic meter. Is it okay? So that means at least 150 kg of cement should be added, okay, for that particular concrete mix. Now this is the minimum requirement. Now in case, one more important thing here I would like to mention here at this juncture is that in case of dry lean concrete, we don't say M10 grade of concrete, M15 grade of concrete, M20 grade of concrete. Okay, a dry lean concrete is defined as a lean concrete, okay, which could achieve or which could produce, okay, a concrete mix which could produce at least 7 MPa, okay, 7 MPa at 7 days. Now here there are two different specifications. 7 MPa is served for dry lean concrete to serve as a as a sub base of the pavement system. Now for another dry lean concrete, if we go for composite pavement, okay, bonded, that means PQC and DLC without the separation membranes, 125 micron thick PVC sheet. Then if they are to be amalgamated, okay, to act as a composite, in that case dry lean concrete concrete mix should have at least 10 MPa, okay, in that case. So now there are two different specifications, so don't get confused in that. So now in our case is like it's simply as a sub-base layer. Therefore we are going to target 7 MPa at 7 days moist curing. Now the one more thing to keep in mind is that in case of dry lean concrete, 28 days strength is not important. 7 days strength of concrete is important. That one has to know. And then coming to PQC. Now PQC is what? Pavement quality concrete. Okay, cement concrete pavements or rigid pavements. But this concrete slab is constructed with, the concrete mix having higher modulus of rupture, higher flexural strength. As per the MOD clause, Ministry of Road Transport and Highways 602, okay, 602, it says that the concrete mix which has the capacity, which has the capability, okay, to produce modulus of rupture of at least 4.5 MPa is, okay, suitable for the constructions of rigid pavement. That's it. But now here the strength again, we can discuss in the two different aspects. The strength, one is the strength to be achieved in the laboratory during formulations of the concrete mix, and the another is the during construction or post construction. Now the strength that we are supposed to achieve at site, okay, that is the characteristic strength of the concrete. Now here in the laboratory, we set a target mean strength. And the target mean strength is nothing, it is strength of the concrete, okay, considering the standard deviations. Is it okay? So now we are taking slightly the higher factor of safety. Okay, so if suppose for 4.5 MPa, okay, 4.5 MPa is required, then the target, when you say the target mean strength, the formula would be 4.5 plus T into standard deviations. The tolerance, T is the tolerance, okay, and into standard deviation. Now this factor, this factor has taken care of the factor of safety. But at site, the strength that you're supposed to get is 4.5 MPa. The minimum that, the characteristic strength of the concrete should be able to achieve when we drill a core sample or when we draw any representative sample from site. That's how. So now, let me take you one by one. This part we have considered. Then now coming to the dry-in concrete pavement construction, I have briefed you and what are the ingredients that we supposed to use, okay? And here, depending upon the availability of the material, say for example, if you intend to admix fly ash, okay, fly ash by part replacing the cement, then because if we part replace the cement or OPC, okay, up to suppose 20% also or 30% also, right, then there would be like, substantial saving with respect to cement consumption. So if the fly ash is abundantly available, okay, in the vicinity of the construction site, then we must go ahead, because fly ash additions will not only reduce the cost of the construction of the project, these admixings of fly ash would, improve the durability property of the concrete as well. In what manner? Because in fly ash, in the SiO2 content is substantial. Therefore, this SiO2 becomes a very useful, component. Why? How it happens? Briefly, I would like to share with you. When this cement and water are admixed together, the chemical reactions produces. And during this process, we are going to get a very useful compound, hydrated compound, that is calcium hydroxide. Okay, that calcium hydroxide, when it comes in contact with the SiO2, these siliceous substances, it is going to give another form of compound, useful compound, which possesses the cementitious properties, that is calcium silicate hydrate gels. So now these additional formations of these additional calcium silicate hydrate gels is really beneficial, okay, for the PQC mix with respect to the durability, because this gel is very fine and adhesive property is very substantial. Therefore, because of the pore filling effect and as well as this, due to this hydration product, which could infill better the pore structure and the porosity of the concrete, so which reduce the porosity level of the concrete significantly. As a result, the concrete manufactured with fly ash is really I consider that it's a very useful, not only in the terms of environmental impact, environmental benefits, not only in terms of the cost reduction benefits, also in terms of durability of the concrete. That's how. So now the fly ash to be used for such kind of concrete shall conform to IS 3812. Okay, so now see, if we have to elaborate, discuss on the fly ash, there we can, this another separate lectures we can plan, because it's a very, in an elaborate way we can discuss. Okay, but due to the paucity of time, what I do is I'm going to briefly explain like this, and I'll take you to other material which are being used for the constructions of different layers of the rigid pavement. Now, coming to the important test on cement and aggregates, this I assume that so I'm not going to brief on that. These are the very basic and fundamental tests, okay, which are to be conducted in the laboratory beforehand. Before we formulate the concrete mix, we have to have these informations. Thereafter only we can proceed for the formulations of concrete mix for the constructions of the rigid pavements. Now, again, coming to the aggregates here, what happening is, now, earlier, for the dry-lean concrete construction, the dry-lean mix, when we formulate the dry-lean mix, we usually, refer the grading, okay, given in IS 383. But now in the new revised IRC SP 49, okay, and a mod clause 601, now the different separate aggregate skeletons is proposed. Now it is quite clear, okay. So now we are going to follow this aggregate skeleton for DLC mix. Now we have to fulfill, okay, we have to select the materials which fulfill this criteria. Now this aggregate skeleton, selections of aggregates, is very, 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 very important. Reason being, majority of this composite is made of aggregates. Is it okay? So it is 75 to 80%, more than 80% are of the aggregates, right? Therefore, if you are looking for a very strong and durable kind of concrete mix, then we need to give more impetus on the selections of aggregates, and while blending the different sizes of aggregates, meeting these grading limits. Okay, we should try always to have in the mid of this specification limit if possible, but practically it is not possible to do that, but nearing to the mid value we should try to keep. Having said that, if we fix our grading, achieve grading very close to this mid specification value, then we tend to get the maximum possible interlocking of aggregates. That's what. And the fine terms, coming to fine aggregates, we prefer to have the sand conforming to grading zone 2 and 3, not 4. Okay, because in the grading zone 1 is the coarser one, zone 2 is slightly finer, and zone 3 is again slightly finer. Zone 4 is not considered. Okay, zone 4 and 5 kind of sand is preferred for plastering of wall and all. So for the structural concrete, we prefer to pick a sand confirming in the grading zone either 2 or 3. 1 is again very if we are looking for the cohesive kind of mix, very high workability, that would affect, because it would be quite harsh in nature because of coarser in size of the fine aggregates. Then now coming to fibers, as I told you that the fibers is being again recommended in the many upcoming projects, especially in some air forces, and not only in air force, in some other rigid pavement projects, national highway projects. In such projects, the fibers is being admixed to control the shrinkage cracking and the post cracking of the rigid pavement slab. But the fibers that we're supposed to use should be conforming to IRC SP 46. Okay, then these are the specifications that we supposed to go by. Now, main important here I would like to mention is, yes, the aspect ratio. That aspect ratio play a pivotal role in the concrete mix. Too much, higher side of aspect ratio would again create a concrete mix very harsh in nature. It is going to affect the workability, okay, significantly. Therefore, aspect ratio is generally recommended in the range of 200 to 2000, okay, not more than that. Then coming to chemical admixtures, yeah, the admixtures depending upon the requirements of the concrete. Is it in our case, pumping concrete is not recommended because very seldom we apply this kind of concrete mix, okay, in constructions abroad. But yes, in a very congested, very highly congested reinforcement kind of structure, then this kind of very flow concrete, very highly flowable concrete is recommended. In such case, the requirements of the superplasizers is also different. But for us, normally in road construction, rigid pavement construction, we prefer to have that kind of superplasizers which shall be able to maintain the what you call the workability to enhance the workability or to prolong the setting of the concrete and so, like that. Okay, so in that way we have a different like set retarding, air entrainment, water reducing, accelerating, shrinkage reducing, chemical admixtures, then the superplasizers, and so on and so forth. So these are the chemical admixtures that if we are looking for retarders, accelerators, right? But the chemical admixtures that we're supposed to use shall got confirmed as per the IS 9103 and IS 6925. And these are the some of the plasticizers and superplasticizers, air entraining agents. Now, to make it a little bit interesting in the lecture. So what I try to do is I try to incorporate the practical practical oriented projects which I personally deal with. These are the few pics I could capture during my site visit when I was supervising the eastern gate of that Taj Mahal. That in the peripheral area of the Taj Mahal, it was completely renovated in the year of 2017. So it was a dream project of the ex-chief minister Akhilesh Yadavji. That point of time, so I was consulted as a consultant for that particular project. It was of around nearing to 200 crore projects. So I was the designer, and then my thought process was significantly, borrowed in this particular renovation projects. So during that point of time, at that point of time, I could capture a few pictures so that I'm sharing with you today. So it is, as you know, that the Taj Mahal, the visitors from the different places of this universe comes and visit this place. Is very crowded place, very difficult to construct the rigid pavement. As you know, rigid pavement construction in such a very narrow width, and where the diversions is a problem, diversions to give an access to other route, is not available. In such circumstances, it becomes a really challenging for the project, engineers to complete this kind of projects. So now the width of the carriageway was 10 meter. So therefore, I had to split into two equal 5 meter, but whereas in IRC 58 2015, the panel size recommended is 4.5 maximum, whereas in these projects, I had 5 meter, 0.5 meter access. So accordingly, the design had to customize. Then accordingly, the regression equations for calculations of flexural stress needs to be customized. So those customization is required from project to project and as and when required. Anyway, that is a different story. But pertaining to constructions of the road rigid pavement, here I would like to share with you the DLC layer construction. Now, the DLC, when we construct the DLC layer prior to laying concrete mix for DLC layer, it is imperative to little bit, slightly, we have to sprinkle water on the subgrade GSB top. Now, this is the GSB top, the first slide here, this one, this is this GSB top. And this has to be properly compacted. The loose particles has to be removed. And then after that, the moisture is slightly, the surface is moistened. Why? Because the dry-lean concrete, it is, in the concrete mix, the water content itself is very limited. Okay. So now if this surface is dry in nature, what would happen? This third surface, now this third surface would try to quench the thirst from the oncoming mix. So that might absorb some moisture, and as a result of which the water content in the DLC would be affected. If that water goes away, then that is going to affect the hydration process, okay, by and large. Therefore, this surface needs to be slightly moistened prior to laying off DLC layer, DLC mix. Then this is the DLC mix. It's a very stiff zero slump concrete. And then after the DLC layer is constructed, then we had a joint site visits. And then after proper curing, ensuring a proper curing, we open up and then we try to measure the undulations, okay, checking the surface irregularity on both sides in the transverse directions and in the longitudinal direction and so on and so forth. So this is how, then now, I was trying to explain them, then there are here undulations. I said, no, this is not going to suffice. This is not acceptable surface. So then now the engineers, the engineer in charge of the projects, now he has to again revamp the surface. So accordingly, then thereafter, the concreting can be proceeded. And now, see, during construction process, this kind of unexpected problem is always anticipated. Now these are the manholes. Okay. Now here during this construction, now we need to take care of this manhole. Now this manhole level has to be taken up at par with the thickness of the pavement, so that tomorrow, as and when required, this manhole should be should be able to operate again. This should be kept in operational mode, for which we need to raise the level. Okay, so that's what, say, in the construction field, when you go to field and the things, different kind of situation you encounter, accordingly you have to take the decision. So I consider that engineer who is a good engineer, I would say that an engineer who has a good practical experience. Okay, only in the laboratory or in theoretically, if you are strong and if you don't have the field exposure, then I would say that still there is a lack in that particular individuals. So we have to have a proper field exposure so that we can synchronize better, with the theory as well as the practical requirements. So coming to the mixes and all, the aggregate selections, now we have to select the materials properly, judiciously, keeping the requirements in mind of like the deleterious contains, sill contains, clay contains, and then mica contains. All this factors should be considered well. Otherwise, what happens is the strength that we desire to get, that targeted strength might not be able to achieve, or in the long run, that the concrete might not, last last for the design period. That's how. Here, as per the IRC 15 and IS 383. Now, this sand, say for example, if I'm just giving you a small example here, it contains larger size of aggregates, and then there are seals, okay, and some foreign matters are there. So these are to be properly diagnosed, these are to be properly screened off, and then we need to screen out this deleterious content, these foreign materials, and then we have to take only the what you call the ideal this thing sand and for the concreting purpose. If we could ensure that, yes, and if you could ensure the workmanship during the construction, then I would say that if the life of the pavement that you targeted, that would, that particular pavement would last more than that. Because in the concrete, the hydration process is, in the continuous process. Okay, continuous process. So if you targeted, if your design life of the pavement is 40 years, I would say it would last more than 40 years, because the concrete, the beauty of the concrete technology is that the hydration process keeps going on, though it might not be that significant, okay, but still that cement grain present, that would keep, hydrating, and therefore the life of the pavement, rigid pavement, is expected to have more than the design life. Whereas in the case of flexible pavement, what happened? If you design for 10 years, it might not last for 10 years, okay? Or if even if that pavement is last for 10 years, beyond 10 years, it is not going to last. Reason being, the binder that we are using is hydrocarbon materials. It is very susceptible to heat, temperature, and it contains a lot of volatile substances. So in due course, when it comes in contact with this, what you call with the oxygens, carbon dioxide, the oxidation rates increases, and the aging process is now rapid. As a result, the life of the pavement is decreasing. Whereas in the case of rigid pavement, it is in the reverse order. Now, these are the the very few pics I would like to share with you. This is the DLC surface. Okay, this is the I've taken from the National Highway Development Project. It was captured in the Madhya Pradesh. I was invited by the NHAI and some contractors and concessionaires to have a visit and address the issues. There were some certain issues in that rigid pavement construction projects. So during that, I captured it. Let me not mention this name of the projects. This is for our just discussion only. Now you can see here the longitudinal cracks is happening here on the DLC layer. Now why this is happening? Now the important thing is that, yes, number one, we must look into the the materials. What kind of material was used? Okay, and as we know, obviously coarse aggregate, fine aggregate, cement, water. These are the main ingredients of the concrete they will be using. Yes, but the important thing is that the deleterious content in the fine aggregates or in that coarse aggregate, that needs to be understood. And then this longitudinal crack is happening. Why? That we need to understand. Okay, now if suppose the DLC layer is constructed and left it for a long period of time, and if the traffic, heavy traffic, is what ply on that, okay, due to the due to the height stresses, vertical compressive strength associated with the horizontal thrust, that might create this kind of cracks. Because now DLC is a lean concrete, okay, which doesn't have a very high modulus of rupture. Therefore, as far as possible, once the DLC layer is constructed, after the 7 days of moist curing, then effort should be made to lay PQC slab on the DLC layer as soon as possible after the 7 days of moist curing. The surface should not be left for a longer period of time. If we leave this surface for a longer period of time, then this kind of distresses are anticipated. Now, when we talk about the constructions of the rigid pavement, constructions of the concrete pavement. The discussion is not limited only up to this rigid pavement. There are some other pavements, okay, which are like, these are the stone, the soling, footpath and all. Now here, this is these pics are collected from the Taj Mahal project, Taj Guns. Okay, so here you can see the challenge of the project was, that I would say it was a great challenge for me. I had to match the, the looks, appearance of the Taj Mahal. Okay, so we have even the pavement also. We had to, pigment it. It was a color pavement. We have to do. We have to construct it. So for which we had to admix some, iron outside. Okay, so that it gives this kind of color. Okay, so the pavement that we construct, I'm going to share with you in the following slide. Before that, I would like to invite you here. So in the construction, you see, these are the subgrade level. Now if the subgrade soil, the subgrade level is, now the subgrade soil is soft and is not properly compacted. And if you happen to erect any, like maybe concrete or maybe of boulder, okay, that is not going to work. Reason being, we need to first of all prepare the bed firmly so that further deformation doesn't take place on placing of heavy structure on it. So that's what during my inspection I was trying to instruct the engineers in charge to revamp the surface, and then accordingly the rectification has to be done. And another important point that I want to point out at this juncture is that, see, the cement, as in constructions of the concrete mix or constructions of rigid pavement, the quality of cement is very important. Now, quality of Dr. Sashi, it should not happen. What is this thing time slot you are giving me?
Sir, it's your wish. Otherwise, the time slot was 1 hour. But
okay, what is the time here for me now?
Sir, you can take the time. Like, we are open here for up to 5 o'clock.
Okay, so I'll try my level best to finish up at the earliest. Okay.
Yes, sir. No problem, sir. Here, I will even sit here after 5 if you say so.
Fine. Thank you. So, but the thing is that our participants, they should not feel bored.
I think they are not feeling bored, sir. They are not feeling bored, sir.
Yes. Okay. So, presuming that they are enjoying, so I'm again extending my lectures.
Okay, sir. Thank you.
If I'm bored to you, please, pardon me. If I'm not, please enjoy my lecture. So, this is the important, again, the factors that I consider during the constructions of the rigid pavement is that now quality of cement. The quality of cement should be monitored throughout the project properly. Now, to do that, we need to have the proper, manufacturing details, like week number, what is the date of manufacturing, the month of manufacturing, right? Because whenever you get a lot of cement, we have to get tested, okay, that the cement property, because that cement property is very important. At times it should happen, the vendor deliberately, they may tend to insert some bad, quality cement. Okay, if you happen to use the bad quality cement, which is already hydrated, okay, then that is going to affect the quality of the concrete. Therefore, proper monitoring during the supply and during the receipt of the cement is very, very important. And at the same time, if the project is, of the mega project, then you have to have a proper storage place for the cement. So the cement storage should be done as per the standard protocol. Then accordingly, you have to, use the cement. Otherwise, I would say the project would be, would be a great disaster. Now, Coming to the aggregates, the batching plant. See, in the batching plant, you have different types of batching plant. This is one of them. And this, see, the batching plant. Now you can see the materials when you know allocate the material samples. Now you have to take care of this material intermixing. Okay, material intermixing. In this case, if now we can see 20 mm is now some portions of 20 mm is already mixed with the 10 mm and right. Okay, now in that case, what happened when this material is dragged through this bucket, and then when this material is fed inside the batching plant in the mixing bin, now what happened, the weight here, the window which is already created exclusively for 10 mm, now it is already contaminated. Partial part of this 10 mm are 20 mm. So that is going to affect the properties of the concrete. Therefore, proper dumping, proper feeding of material during the manufacturing of concrete is very, very important. Now, and also at the same time, what I consider is during at the stockpile, while stockpiling the materials, different sizes of aggregates should be properly separately stacked so that they are not intermix each other. Now here you can see the sand and aggregates, they are very close by. This kind of the stack yard is not preferred. So that's what I was suggesting them. Then I climb up to these heaps of the aggregates and try to look at. Then I gave them a proper suggestion not to be done like that. So that's how the project was monitored. And the remaining part of this, sorry, I didn't know. Now the sand, this sand heaps, we have to see for a successful executions of any project. See, we have to have a very good team. Good team in the sense, contractor is also one of the team members. Okay, he is he should be very proactive, and he should have a quality conscious mind. And if he is conscious on quality, I would say the project is going to be a really successful project. Otherwise, if he is not aware of the importance of the quality of the project, the quality of the materials, quality of the constructions, it is very difficult to monitor it. But fortunately, in that particular project, we had a very good contractors, because of which we did not face much of problem. And then this project, was a great success. And today, if I happen to go to, the Taj Mahal, I feel really proud that, that now it's things have very changed, and we have revamped, and and then we have done it in a very beautiful manner, in a presentable way, better than previous one. So now this is the DLC layer. That's what it is. We haven't add the pigments here. The pigmented part I would like to share with you in the subsequent slides. Now coming to in the National Highway project, see, this is a very small example I'm giving you. This is again in one of the site in the National Highway 72. I was invited for the site visit by the contractors and the NHAI. So when I been to that site visit, I got the opportunity to collect few picture that I'm sharing with you. This is how the PQC mix is dumped in front of the slip form paver, and then this kind of Portland, this kind of excavator is used to lift the materials and spread the materials, because as I told you a little while ago, PQC mix is very stiff, not the slum concrete. Therefore, while leveling, so it becomes very difficult for paver to drag the material from one end to another. Now, the fresh concrete properties that we are looking at is slum has to have a 20 to 30 mm, and super plus sizes doses has to be admixed based on the manufacturer certificates recommendations. But For this to be precise, I would say we have to find the exact doses of these superplasizers in the laboratory by conducting mass quant tests. Okay, I repeat, mass quant tests. It is a test by which we can ascertain the specific doses of chemical admixtures to be added for that particular cement. And then entrapped air should not be more than 3%, okay, to ensure the durable concrete. And entrapped air we can add up to maximum 6.5% to ensure a freeze and thaw, to increase the freeze and thaw resistance. And for the PQC mix, as per mod clause 602, water cement ratio recommended is maximum 0.4. And the cement content per cubic meter of concrete recommended is 450 kg per cubic meter. And minimum, without any admixtures, the bare minimum cement content per cubic meter of concrete shall be 360 kg per cubic meter. And if we intend to use fly ash, up to 25% fly ash can be used. And in that case, the cement content per cubic meter of concrete shall be at least 310. This is how the concrete, pavement is paved, and then it has been smoothened, and then proper texturing has to be done. Texturing is done to to create some friction, okay, between the vehicle tire and the concrete surface. So that proper texturing needs to be done as per IRC 15, okay, and as per MORTH clause 600 section. Okay, so texturing is done normally to a depth of on an average of 1.25 mm, not too depth, not too shallow. Okay, so that kind of texturing depth is required. And once the concreting is done, then we have to ensure the proper curing. So for curing, we need proper curing compound. Now, what should be the curing compound? The resin-based aluminized reflective curing compound is recommended, or white pigmented curing compound, which hardens into impervious film. Okay, and the curing compound that we use shall conform to ASTM-C 309 and the British standard 7542, and that curing compound shall have the water retention efficiency index not less than 90%. Now, I was talking about the separation membranes, 125 micron thick PVC sheet, okay, polyvinyl chloride sheet. This is the one. Now, while spreading this PVC sheet, this sheet is spreaded on top of the DLC layer, okay. Now this, while spreading this, it should avoid the creases. So we should remove the creases, for which this sheet should be properly anchored. It should be properly stick to the DLC layer, so that when the construction vehicles, okay, the trucks, the tipper is fetching the materials onto the paver, okay, paver hopper. At that point of time, this sheet should not peel off. So that we need to consider, for which proper sticking of these separation membranes is required. Now, this is the the concrete mix after admixing of iron oxide. Now, after admixing of this iron oxide, we could see the color has changed. The color of concrete has changed. Now, this color is now matching with the Taj Mahal, that one. Okay, the what you call the surrounding. So, in order to match that, we had to admix this iron oxide. Okay. So this was the requirement from the Supreme Court. Okay, the Supreme Court decided that now whatever the structure you build here, that should match with the existing Taj Mahal structure. Okay, so that which is why we had to add this. Now the separation membranes in the larger form you will find in this way, and at times it is not necessary that the separation membranes has to be only in white color. At times, this kind of bluish color also employed. Then now coming to, I'm going to finish my presentations. I'm about to finish. So now that here, while providing joints, it is imperative to align the dowel bars and tie bars at a predetermined location properly. So now this kind of basket arrangements are provided to ensure that the dowel bars are aligned as per the design. Now this alignment is done at the neutral axis or at the the center of the slab thickness, so that after taking the measurements and this height and spacing, depending upon the design we have to do, and this kind of epoxy coating is done. This is the non-corrosive materials, so that the dowel bars are not corrode. And this, otherwise this kind of practice also we adopted. Now this is about 60% of the dowel bar is plastic sheeting to avoid the bond between the concrete and the dowel bar, so that when these dowel bars are embedded inside the concrete, now then when the concrete is hardened, then there should be a small window through which that the movements of the slab concrete is possible. Because during the contraction and expansions of the concrete, that movement this would facilitate the slight movement of the slab. Otherwise, what happens if it is completely restrained? Then it is going to occur cracks. Okay. Now, in this kind of joints, there are types of joints. Like this is U-type dowel. Okay. This is U-type dowel. It is properly anchored here, firmly anchored. And here this is J-type. Earlier people used to adopt this kind of joint type also while fixing the dowel bar, but this is not successful. Therefore, I am showing that this is preferred over than this. The reason being, now these dowel bars are to be fixed firmly because we are going to pour a concrete mix on it. Now the whole assembly will be embedded, okay, within the concrete mix. Therefore, now see, separation membranes is spreaded, and then upon that, dowel bars and aligned on the dowel bar baskets are seen here. Okay, this is how. And whereas in the case of slip form paver, here there is a dowel bar inserter. Okay, in the dowel bar insert, the previous slide was for the manual construction, and here this is, you can see the dowel bars are aligned and at the predetermined location at every 4.5 meter interval. With the help of this dowel bar inserter, the dowel bars would be embedded within the concrete mix at the predetermined location at the predetermined height. Okay, so this is my research team along with few MTech students. I've taken them. I've taken to the site. I like taking my students to site and and explain, so that they are acclimatized and they are aware what exactly what kind of feel you get when you go to field at site during construction. You need to have the feel. Only I believe that theory and the practical class should be taken up parallelly. So with the concept of that, I always try to take my students to site. Then coming to the dowel bars and tie bars. Okay, now in the IRC 58, as I told you, dowel bars are to be designed, tie bars are to be designed for the given axial load spectrum and for the given K value, modulus of subgrade reaction, soil properties, and for the selected grade of concrete, and in that way we design. So I have discussed with you in brief, and now the final call is that joint sealing, right? We know we have talked about the joints. Joints are provided. Joints are very important in the resist pavement system. The joints are provided at the predetermined location at every 4.5 meter intervals. So now these joints are inevitable now. Okay, so now to have a good load transference from one slab to another. Now you can see here this figure. Here the dowel bar is now inserted here, And when the wheel load is on in this slab, now we assume that about 40 to 50% of this wheel load is already being transferred to this adjacent slab, which is why the dowel bar is being employed. And the joint cutting, is now done here up to normally 1/3 or to 1/4 of total depth of the slab. Why this cutting is done? The reason being, why this cutting is not being done through and through? Reason being, this is just to initiate the cracks, okay, of the pavement slab. Now from here on, now you see the occurrence of cracks in the natural way. Now these cracks are what? Very occurring in a natural form. Therefore, what happening is when the vehicle comes on this, now the through aggregate, the certain percentage of load would be transferred from this to this or vice versa. Is it okay? If we cut this joint through and through, then this concept, this philosophy, now this load transference through aggregate system would be eliminated. Okay, therefore now this cutting is done up to 1/3 to 1/4. It's solely to initiate the cracks at the predetermined location, so that now the stresses here, which is supposed to build here at this location, is being released here. Otherwise, what would happen? Unwanted cracks might occur in a very randomly. That would be in a very uncontrolled manner. Now here at a controlled manner, if we are able to monitor the cracks, okay. Then now joints. Coming to joints, we have contraction joints, expansion joints, construction joints, longitudinal joints. Now again, to deliberate on this, I need more time. Okay, I need this substantial amount of time. Okay, that I wouldn't be able to, I wouldn't be doing now. But there are different types of joints. So these joints which is being provided parallel to the this thing that traffic movement is the longitudinal joint. As I told you in my at the very beginning, longitudinal joint is recommended when the pavement width is more than 4.5 meter. And contraction joint, let us assume that in this way the traffic is moving, then this would be the contraction joint. Now this joint opening has to be again infilled with the proper sealants, so that now if this sealant is not provided here, what happens during the contractions and expansions process, these two slab edges may are likely to come and collide, and then buckling might take place. Okay, therefore in order to avoid that kind of distresses, it is imperative to have a sealant out here. Now sealant, the quality of sealant should be like, it should have a proper movement accommodation factor. That means elastic recovery system should be good. Now when it comes, when it's squeezed down, suppose now this is squeezed, then now in that case, now under the circumstances, the sealant would be what? Compress. Okay, under the compression. Then once the vehicle wheels move away from this particular locations, then it should be able to goes back to its original position. That kind of sealant has to be used. Now the joint cutting is again another important issue. If untimely joint cutting creates another problem, okay, creates a shrinkage cracks. Like this is a good example here. This is a shrinkage cracks possibly due to late sewing. If the sewing is done very late, okay, then this kind of shrinkage crack is going to happen, because the stress development within the concrete slab would be tremendous. So therefore it is going to burst out somewhere in the weaker sections of the concrete slab. And in a very similar way here, if the joint cutting is done too early, then revealing this kind of distress is likely to occur. Okay, and now when we talk about the filling of joints, one important joint I would like to mention here, that is expansion joint. The expansion joint is a joint, it is a full depth joint. Here in my previous slide, what happened, I did tell you that this is the contraction joint. Okay, the contraction joint is to be provided at the 4.5 meter intervals. This is solely provided for what? To relieve the tensile stress. Okay. Now, in the case of this expansion joint is, yep, it would be full depth cutting through and through. Okay. And the width of the joint would be in the range of 20 to 25 mm. Now, in that case, dowel bar has to be inserted, okay, at the middle of this slab, and the compressive filler board, this one, the compressive filler board has to be, inserted, so that when this, the reason being, the expansion joint is provided whenever the concrete slab abuts with the permanent structure, like bridge, culverts. At that juncture, at that location, the expansion joint has to be provided. Now, what happened at that location? The compressive stress, vertical stress, horizontal stress are, more prominent. Therefore, the thrust which is going to come is tremendous. So, in order to counterattack that kind of thrust, we have to have a wider joint, and it should be full depth joint. Okay, that in that kind of joint, the compressive filler board is provided. So this is a good example of that. So then the sealants to be employed for in filling the joints are like, we can do hot porcelain, cold porcelains. Normally we prefer to use the cold porcelains. Then the sealants are what we call a prepare in the form of base. Now we have a primer, okay, base, and then we have what we call hardener. Okay, so we have to mix in a certain doses, certain percentage, and then we have to prepare that sealant, and that sealant has to be a certain the elastic recovery effect that we talk in terms of movement accommodation factor. So after compression, after extension, so as per IRC 57, the minimum required is like the -30, and here we get in the result, say for example 49, that means it is passed. And here the minimum required in the compression after extension, minimum 30 plus, here we get 35.5, that means this is good. The sealant provided is good. But this particular sealant was used in the Chandigarh Air Force. Actually, the Chandigarh Air Force, the extension part was, that part was designed by me, and I was actively involved for the construction and the designing of that particular extensions of the Chandigarh Air Force. So that that report I am sharing with you. And another important factor for sealant is sap factor. Now the sap factor recommended for this thing, different sealant is hot porcelain. It should range in the range of 1 to 1.25. By the way, what is the sap factor? Sap factor is the ratio of depth of sealant, okay, to width of sealant. So now this is the sap, okay, sap factor. This sealant. Now this is when the slab is contract, it would have the pilling effect, and when the slab is in expanse, it would compress it. So now the sap factor should retain properly. Otherwise, what would happen? There would be some brittleness. There would be some, defects. That sorts of things should not happen during the, design life. Therefore, the sap factor is also important. Then this is fine. Then finally, this is the last slide. We check the texture depth. Okay, texture depth is like, it's a kind of like we to avoid the skidding effects. Okay, particularly, especially when there is water on the concrete surface, it should not be, there shouldn't be any skidding effect. Okay, therefore we have to have a proper texture depth. Okay, we have to have a proper, we have to do the you have to provide a proper texturing depth. To measure that, we have to use the glass beads. Glass bead is also material, because today my lecture is on the materials used for the different layers of the rigid pavement construction. Therefore, this is also a glass bead. Okay, this, with the help of this glass bead, we ascertain the texture depth. So this is how we use the hockey pucks and all, and then finally we measure the texture depth. The average, the texture depths recommended for a concrete surface, rigid pavement surface, is 1.25 mm. Okay, so this is how my discussions, for pertaining to different layers for rigid pavement is concerned. I do hope you enjoy my lectures. There are so many more to discuss. I'm sorry today I was a bit down. My health was a bit down for the past 1-2 weeks. I was not well. So, but nevertheless, I tried my level best to interact with you. So to make not to make you bored. Yeah, at a very some in my beginning slide, I was slow. I thought that no, I shouldn't be doing that. I should do justice towards my lectures with my participants. So I hope you enjoy. And if there is any query, I love to address. I would love to attend that. If I cannot do, I will say sorry. I'll find and I'll come back to you later. Thank you.
Thank you, sir. Sir, the queries must be there at the chat box. If you could see the chat box, there are appreciations also. Please see the chat box.
Okay. I guess.
Yes, sir, sir, where the mark of 80 is written. Uh, yes, near to the time. On the left, right hand side, top corner.
Yeah. Resume your presentation after the turn off your captions.
Yes, sir, here. This 80. Yes, yes,
Okay.
80.
Okay. How many participants?
Right now, there are 63 participants, sir, but queries are very large in number. So if you
Barbara.
could take some queries.
Ah. Okay. Okay. Well, very nice. I'll come up. Oh my God. I really love it.
Thank you, sir. Thank you. Thank you for obliging us.
Uh, okay. Okay. My voice was not clear, right, for some time.
Yes, sir, in the starting, but then it is okay. In between, the people have posted some queries also.
Hmm. So let me take up one by one, right?
Yes, sir, definitely.
Yeah. Vamsi Kalyan Birla has a query about the cost of CC roads are higher than costs for the bituminous road as of now. Is it not? Okay, true, but I would say in that way, yes. Today, I would say since in the receipt payment we are able to accommodate more percentage of waste materials. Okay, for example, I'll give you a very small example. Citing my ongoing research project. Now we are trying to use the construction demolished waste. Okay. Now in that case, we would be able to reduce the cost of constructions of rigid pavement. Okay, considerably. Yes, still it would be on the higher side in comparison to bituminous concrete rod. Okay, but if we consider the life cycle costs of the cement concrete pavement, yeah, there would be a significant difference, in terms of saving by the rigid pavement when compared to flexible pavement. Now, uh, to be a little bit precise, in rigid pavement nowadays in the modern concrete, we are trying to use like waste material like fly ash. Okay, fly ash in the like the where in the project for the project. Okay, in the project and in the nearby, if the fly ash is abundantly available, if we are able to part replace the cement by up to 30-35% also, then that would considerably reduce the cost of the rigid pavement construction. That is one. And and then at the same time, considering the durability of concrete that we are going to have out of this exercise, means at mixing of this kind of pozzolan, it's really a tremendous, okay, in the long run. So in that way I would say yes, it is a it is a very sustainable kind of construction, except the energy that you know the energy required during the productions of the cement, the manufacturing, and the raw material processing, and those are there, that that we cannot this thing ignore it. But if we compare the cost of construction, so with respect to the materials available in today's time, I would say we can reduce the cost of construction substantially. In current, the ongoing research project, which is being, you know, uh, currently conducted by our research group, if you look at, we are trying to incorporate wrap material, reclaim asphalt pavement materials in the concrete pavement for the concrete mix for the constructions of rigid pavement. Okay. Now, wrap material is what? It is, that it is a mixture of aged asphalt, aged asphalt, which is being milled off from the existing pavement system, okay, and which otherwise it's waste materials. Though we are using this waste material in the constructions of flexible pavement, also we are reusing in the bituminous mix, but the percentage of your usage of wrap in the bituminous mix is very only limiting up to again 25-30%. Okay, and then how about the 70%? That's the question. So based on that, we have done a very extensive laboratory investigations and followed by some trial sections. And through these findings, through these exercises, what we got to learn is that wrap materials can be incorporated up to 75%. Now you must be wondering, how can it be possible? How can the wrap material can be incorporated, in the conventional concrete mix? Because the problem here is the challenge that we have is the asphalt film. Okay, asphalt film which is engulfing around the aggregates. This is creating, a hurdle, because it is not able to have a good bonding between the hydrated cement paste and the aggregate at the aggregate interface. But we have devised a small, a very simple and doable methods. What we call that is called AB and AT methods. Okay, by mechanical beneficiation methods, we are able to puncture the asphalt film which is coating around the aggregates, which is why now we are able to create enough room at the interface of the aggregates and interface at the aggregates, so that hydrated cement compound can come in, interact and attach to it, and has have a good bonding. So in that perspective, we have a good this thing publications also. We have tried to communicate our thought process in the library world, in the STM, SAE, and also and so forth. And people are appreciating, and and we are also working further. And yes, in one of the comment I have seen that regarding the geopolymer concrete, there he mentioned that the geopolymer concrete can be used for the road construction. One of the participants has raised these questions. Let me just pick the right questions. Yeah. What do you feel? Okay, the question is collected from
uh, as has been already conveyed to you on the chat box, due to power shortage, we were not able to maintain contact with the speaker. And the speaker has called me and he has told that if people are having queries, then that would be answered through email communication. So you are all welcome to send your queries through email to the institutional email ID of the speaker. Once again, this disconnection is regretted, and I hope that this lecture was quite informative and you can say a very practical know-how of the things have been given to you. So, thank you very much. In case, see, there would not be any kind of what I could see here is People are asking that feedback link. There is no feedback link for today's webinar. It would be there only for STC. So it is just for your information sake. So that's why we did not put any kind of feedback link for this. If you have queries, you can post it to the speaker's end. So I once again I will again thank you to be a part of this webinar, and in the future we would be posting you for the further webinars which would be conducted by our end, and even we are planning to hold one STC. So that would be conveyed to you through emails. So thank you very much. And yes, we would be sharing the PPT on a YouTube institutional channel. That is the NITJ YouTube channel. This would be available in couple of days, like 4 or 5 days. So please be there and check it out. You can check it out very easily. Open YouTube, put NITJ channel, and in that you will see the webinars conducted by the NITJ. So thank you very much.